Hey guys, welcome back to Google Foundation online classroom. Today we'll be starting with a topic in trigonometry. So this will be the video or part one of trigonometry. Let me take you through my presentation. Okay. This is one of my favorite quotes by Nelson Mandela. He says, "It always seems impossible until it is done." So this will be trigonometry 1. So the focus of the lesson, we'll look at the revision for grade 11, and then we'll look at the trig ratios, and then we'll look at the cast diagram, and then we'll also look at the solving triangle with trigs or trig ratios, and then we'll also look at the special angles, we'll look at the cofunctions, we'll look at the reduction formulae, and lastly we'll look at the negative angles. So here, trigonometry is coming from the Greek word trigonon, meaning triangle, and metron, meaning measure. So this is a branch of mathematics that studies the relationship between side length and angles of triangles. So trig ratios will be using theta as our reference angle. So suppose here you've got theta as our reference angle. So opposite to theta, you've got opposite side. So, and then here you've got adjacent side. So that is the side which is next to theta. And then opposite to the right angle triangle, you've got the hypotenuse. So suppose you are given, let's use sine. You'll have a sine theta, it will be opposite or over hypotenuse. Opposite over hypotenuse. So we've got so, and then now we've got cos, which will be adjacent over hypotenuse. We've got k a over h. And then now you've got tan, which is opposite over adjacent, which is O over A. Now, let's look at some revisions and theorem of Pythagoras. So in any right angle triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. So in other words, we're saying that r squared, which is this radius, will be the sum of x squared plus y squared. And then for sine theta, you'll have opposite over hypotenuse, y over r. And then for cos theta, you'll have adjacent, which is x over r. And then for tan, you'll have opposite over adjacent, which is y over x. Now, let's look at the grade 11 identities recap. So we've got a quotient identity, which is tan theta is equals to sin theta over cos theta, whereby your cos theta will never be equal to 0. And then we have got a square identity, square identity, which is sin squared theta plus cos squared theta is equals to 1. And then it follows, if you make sin squared theta subject to the formula, you'll have 1 minus cos squared theta. If you make cos squared theta subject to the formula, you'll have 1 minus sin squared theta. This is interesting. Now, let's look at example number 1. So here in example number 1, you've got the right angle triangle MNP. So you've given triangle MN is a right angle triangle. Write down the trig ratios for sine alpha. Here you've got sine alpha, which will be opposite MN over hypotenuse, MN over MP, right? And then for sine beta, you have got beta here, it will be opposite over hypotenuse, which is MN over MP, right? And then they're saying that tan beta equals alpha if MP is equals to 13 and NP is equals to 5. Calculate cos theta. So basically will be will be having sin alpha, I said that it's mn over mp, and then sin beta, I said it will be np over mp, and then tan beta, I said it will be opposite np over adjacent mn, and then cos alpha, it will be equal to cos alpha, it will be adjacent over hypotenuse, which is np over mp. Now they're saying that if mp is equal to 13, if mp is equal to 13 and np is equal to 5, so we can find mp, right? So by theorem of Pythagoras, mp squared is equal to mn squared plus np. So you are 13 squared. So here we can find mn. So you've got 13 squared is equal to mn squared plus 5 squared, right? So you transfer this to the other side. So you will have 169 minus 25, and then your mn is equal to 144. Then you get a square root. You will have mn is equal to 12. And then cos beta, it will be adjacent over hypotenuse, which is 12 over 13. Now let's look at the cast diagram. So we're saying that the Cartesian plane has 4 quadrants. This is your first quadrant, second quadrant, third quadrant, and the fourth quadrant. So now here in terms of degree, you've got 0 degree plus 90, you've got 90 degrees plus 90, you've got 180 plus 90, you've got 270 plus 90, you've got 360 degrees. So here, in other words, we're saying that we're saying that is cast diagram because C-A-S-T, that's cast. So now for you, here A is saying that all trig ratios are positive, and then here S is saying that sign here is positive, the rest negative. Here tan is positive on third quadrant, the rest negative. Here cos is positive, the rest negative. So some also say, you know, they say all students take chocolate, something like that. So now let's look at example number 2. If tan theta is equal to negative root of 3 and 180 less than, theta is less than 180 and less than 360, determine using a diagram the value of sin alpha and 3 cos alpha. So for you, you have to know that tan theta, we said is equal to opposite over adjacent. So here you've got over 1. So you have to also have to ask yourself 180. So where tan is positive, tan is negative in the fourth quadrant. So you're going to draw your diagram in the fourth quadrant, and then it means that your opposite here is y over x, right? So your diagram here, this will be your diagram here. So tan theta is equal to y over x is equal to negative root of 3 over 1. So here is opposite, which is your opposite is y, and then your x is 1. So you can calculate the r, the remaining side. So you use the theorem of Pythagoras. It will be 1 squared plus negative root of 3 squared. So r squared is equal to 1 plus 3, which is equal to 4. Then you get the square root, you get r is equal to 2. So for you to determine tan theta, you'll have opposite over hypotenuse. So you'll have y over r, negative root of 3, this is y, this side, over 2 over hypotenuse. So 3 cos theta, you'll also get from the diagram. So if this is your theta, it should be adjacent over hypotenuse. So your adjacent is x is 1, hypotenuse is 2. So it will be 3 into 1 over 2, which is 3 over 2, which is equivalent to 1,5. That's simple. So example number 3, in the diagram below, the reflex TOP is equal to alpha and p as the coordinate here, -5, -12. So just note that here for -5 is x and then -12 is y. Okay. Determine the value of each of the following trigonometric using trigonometric ratio without using the calculator, so cos alpha. So here you just have to say x here is at the negative, and then y is also at the negative, negative 12. Then you can calculate r. This will be simple. And then now you calculate r. You say r squared is equal to x squared plus y squared, which is negative 5 squared, which is 25, and then negative 12, which is 144, right? Which is equal to 169. And then r, get the square root of 169, it will be 13. So you can come and determine cos alpha. Cos alpha, which will be adjacent over hypotenuse, is negative 5 over hypotenuse, which is 13. That's why you got negative 5 over 13. So for tan theta, for tan 180 minus alpha on number 2 here, so your tan is negative in the second quadrant. So you write negative tan theta, and then you work from the diagram, tan alpha, it will be opposite over adjacent. So it will be negative 12 over negative 12 over negative 5. And then this negative and negative will cancel out. Then you are left with the negative from the tan. Okay. Now let's look at the special angles. So these angles, they are special. So these values are useful when you need to solve a problem involving trigonometric functions without using a calculator. So for example, we'll look at the 30 degrees and 60 degrees as a special angle. So we'll use the equilateral triangle. So equilateral triangle, that's a triangle whereby two equal sides are equal, right? We have got two equal sides. So, and then equilateral, it means that, I mean, like all those angles are equal. The sides, you know, are equal, and that has got sides of 2 units. So now this is your equilateral triangle. All these sides are equal, which implies that the base angle here are also equal. So here you've got 60, here you've got 60, and here you've got 60. So if we try to divide it, that 60, we divide the angle, it will be 30, 30, and then here it will be 1, 1. From these two, it will be 1, 1. Okay, which will boil to, here you got 32 and 1. So you can calculate the remaining side by a theorem of Pythagoras. So this will be y, and then when you work it out, you have got this PS, it will be equal to, you know, it will be equal to 2 squared minus 1 squared from theorem of Pythagoras, which will give you 3, and then you get the square root, which will be root 3. And now for you to use the trig ratio sin 60, so we say we use this without the use of a calculator. Okay, sin 60 from the diagram, it will be opposite over hypotenuse. You've got root 3 over 2, and then sin cos 60, it will be adjacent over hypotenuse 1 over 2, and then tan 60, it will be opposite over adjacent root 3 over 1, which is equivalent to root 3. Okay, so now sin 30, now your 30 is up here, it will be opposite over hypotenuse 1 over 2, and then your cos 30, it will be adjacent over hypotenuse root 3 over 2, and then now your tan 30, it will be opposite over adjacent, will be 1 over root of 3, and then you rationalize here. So when you rationalize, you multiply denominator by root of 3 and the numerator by root of 3. So you'll end up having 3 here and then root of 3 this side. Now let's look at the special angle of 45 degrees. So here we'll use isosceles triangles. Here in the isosceles triangle, that's where two sides are equal, right? But in the equilateral triangle, all sides are equal. So which means the base angle inside are equal. So here, the isosceles triangles mean that two sides are equal, right? So you've got two sides here equal. This side here, 1 unit is equal. So it means the base angle here, the base angle are also equal. So now, if here is 1, it will be 1 squared plus 1 squared, and then you get this side by a theorem of Pythagoras, which will be 2 root 2. Okay, now for us to use it tan 45, you can work here or use this, doesn't matter. So let's use this angle tan 45. It will be opposite over adjacent, which will be 1 over 1, which is 1. And then sine 45, it will be opposite over hypotenuse, which is 1 over root of 2. And then for you to rationalize, you multiply denominator and the numerator by root of 2, which will give you root of 2 over 2. And then for cos 45 here, you've got adjacent, which is 1 over hypotenuse, which is root of 2. And then 1 over root of 2, and then you rationalize, which will give you, root of 2 over 2. This should be simple. Then in example number 4, evaluate without the using of a calculator. You have given 2 sin 30 plus 3 cos 60 minus 3 tan 45. And then 1b, you have given 3 into cos 30 squared plus 2 sin 30 squared. So all these, they are special angles, 30, 60, 45, all these, they are special angles. So you don't have to use the calculator, because if you use the calculator, you might end up getting answer which is already rationalized, because the calculator is sort of a programmed. So now let's do this. Sin 30, it is 1 over 2, it should be 2 into 1 over 2 plus 3 into sin 60, 1 over 2 from those diagrams. And then tan 45 is 1 over 1, which is 1. And then it should be 2 over 2 here, which is 1, and 3 over 2 minus 3, which is negative half. So number B, we have got cos 30, which is 3 into root of 3 over 2, right? And then squared plus 2 into sin 30 is 1 over 2 squared. So now you've got 3 squared, root of 3 squared, when you squared is 3, and then 2 squared is 4, plus 2 into 1 over 4. So you've got 9 over 4 plus 2 over 4. Your LCD is 4, your lowest common denominator is 4. So you just say 9 plus 2 over 4, which is 11. So now let's look at the cofunctions. These we've got complementary angles. These are angles that add up to 90 degrees. Sine and cos are cofunctions of each other at what? At 90 degrees, right? So check this out. For example, sine of 90 minus theta is equals to cos theta. Why? Because 90 minus theta, that's in first quadrant, and then sine there is positive. Is it a cofunction? Yes, it's 90. So it will be cos theta. And then now 90 plus theta is in the second quadrant. Is this sign there positive or negative? Positive. Then is it a cofunction? Yes, you write cos theta. You write its cofunction. So now let's look at the cos of 90 minus theta. 90 minus theta is in the first quadrant. Is cos there positive or negative? Positive. Is it a cofunction? Yes, you write sin theta. So cos of 90 plus theta. 90 plus theta is in the second quadrant. Is cos there positive or negative? Negative. Is it a cofunction? Yes. Then you write negative. So now let's look at the reduction formulae. So here the reduction formulae, it holds for any angle theta. So we assume that theta is an acute angle, meaning that it's less than 90. Is any angle, acute angle is any angle less than 90 degrees. So now you function values of 180 degrees minus or plus theta, or 360 minus or plus theta, and negative theta, the function does not change. In other words, they are not cofunctions, it does not change. And then the function values of 90 degrees plus or minus theta, or 270 minus or plus theta, the function changes to its co-function. But not that in your syllabus, this 270 is not there in your syllabus. So for you guys, you will only work with 90 minus or plus, and then that way sine will change to cos, and like that, cos will change to sine. And now your direction is anti-clockwise. It's anti-clockwise. It's anti-clockwise for the reduction formula. Okay. Now let's look here. You've got A, meaning all are positive. So here we say A, all functions are positive in the first quadrant. Here you've got 0 degree, plus 90 is 90 degrees, and here you've got 180. So let's look here first. So sine 360 plus theta. So 360 plus theta is in the first quadrant. Isn't there positive? Yes, it's positive. So it will be positive. Is it a cofunction? No, it will remain the same. It does not change. That's what we say. So cos 360 plus theta is in the first quadrant. Is cos there positive? Yes. Is it a cofunction? No. So it will remain the same. It will be cos theta. So here, tan of 360 plus theta is in which quadrant? It's in the first quadrant. Is tan there positive or negative? Is positive. Is it a cofunction? No, does not change. So sine here is a 90 minus theta. So here you are in here now, 90 minus theta, you are here. So sine 90 minus theta is in the first quadrant. Is sine there positive? Yes. Is it a cofunction? Yes. So the sign will change to cos. So for cos 90 minus theta, you will be in the first quadrant. Is cos there positive or negative? Is positive. Is it a cofunction? Yes. It will change to sine. So now let's go to second quadrant. For sine function is sine is positive here. S, you've got S, sine is positive. So sine 180 minus theta. Is it a, you ask yourself two questions. Sine 180 minus theta, which quadrant is in second quadrant? Is sine there positive or negative? Is positive. Is it a cofunction? No, it will remain the same. It will be sine theta. So cos of 180 minus theta, is it a, which quadrant is second quadrant? Is cos there positive or negative? Is negative. Then you write negative. Is it a cofunction or not? It's not a cofunction. 180 degrees is not a cofunction. Okay, we say cofunctions are 90 and 270. So now for tan 180 minus theta, you are given tan 180 minus theta second quadrant. Is tan there positive or negative? Negative. Is it a cofunction? No, it will be tan theta. Sine 90 plus theta, which quadrant? 90 plus theta is here in this quadrant, second quadrant. Is sine there positive or negative? Sine there is positive. Okay, is it a cofunction? Yes, it will be cos theta. So 90 plus theta, 90 plus theta, which quadrant? Second quadrant. Is cos there positive or negative? Cos is negative. Is it a cofunction? Yes, it will be sin theta. So this should be simple. This will be very simple. Now, let's look here in the third quadrant. We're saying that the tangent is, or tan is positive, the rest are negative. So sine 180 plus theta, sine 180 here plus theta. Which quadrant is this? Is third quadrant. Isn't there positive or negative? It's negative. Is it a cofunction? No, it will be the same, sine theta. Cos of 180 plus theta is which quadrant? Third quadrant. Is cos there positive or negative? Negative. Is it a cofunction? No, it will be the same. It will be cos theta. So now tan of 180 plus theta, which quadrant? Third quadrant. Is tan positive or negative? It's positive. So it will be the same. It's not a cofunction. So now let's look at the fourth quadrant. Here you've got 270. Let's look at the fourth quadrant. What is happening? Cos, doesn't that see? Cos is positive. Now you are sine 360 minus theta. Which quadrant? Then 360 minus theta. Which quadrant? Fourth quadrant. Is sine there positive or negative? It's negative. So is it a cofunction or not? It's not a cofunction. It will be the same. Sine theta. So cos of 360 minus theta, which quadrant? Fourth quadrant. Is cos there positive or negative? It will be positive. Is it a cofunction or no? It will be the same. Tan of 360 minus theta, which quadrant? Fourth quadrant. Is tan there positive or negative? It's negative. That's not its position. So it will be tan theta. So now, let's look at the example number 5. Evaluate, find the value of sine of 135 without the use of a calculator. Okay, so now sine 135 is equals to sine of 180 minus 45. You just minus the special angle, and then down sine of 180 will be sine of 45. And then sine 45 is equals to root of 2 over 2, right? So now let's look at example number 6. Simplify the following. You've got cos 135 tan 45 sin 20 tan 210 cos 70. So you can here, you've given cos of 135, you can say 180 minus 45, and this 45 is, it will be like that, tan of 210. You can just change here, you manipulate here, and then also you can change this one to a cofunction. So you will have something like this: cos of 180 minus 45, and then tan of 45, it will be like that, sine of 20, and then tan of 210, it will be 180 plus 30, multiplied by cos of 90 minus 20, 90 minus 20, which is equivalent to 70. So now this is interesting. Their cos is negative, it will be cos of negative 45, then tan 45 will be like that, sine of 20, then 180 plus 30, tan is positive there, it will be tan 30. So now here, this will change to a cofunction of 20, so that the 20 and 20 will cancel out, right? So now you have got negative root of 2 over 2 multiplied by 1. Tan 45 is 1 over 1, which is 1. And then tan 30 here is 1 over root of 3. Then this is a long division. So when you convert it, you multiply, then your numerator will become the denominator, and the denominator will become the numerator. So you multiply it here, you'll end up having negative root of 6 over 2. So let's look at example number 7. So now you simplify the following: sine of 180 plus theta multiplied by cos of 360 minus theta over tan 180 minus theta plus cos squared theta. So now this should be this easy, because 180 plus theta, sine there is negative, v negative sin theta, and then cos of 360 there is positive cos theta, and then tan of 180 minus theta there is negative tan theta plus cos squared theta. So you can also change this sign. So negative and negative will be positive, so we'll cancel out. Then you can change this tan into sine over cos. Are we together? So now this is a long division. When you change it, division into multiplication, the numerator become the numerator become the denominator, and the denominator become the numerator. So now you'll be cos over sine plus cos squared theta. So now the sine and the sine can cancel out. Then you are left with cos and cos, which will be cos squared theta plus cos squared theta, which is 2 cos squared theta. This is simple. So now angles greater than 360. You know, sometimes you can be given 720, you can given 500, and all that. So how do? We add or subtract 360 or multiples of 360. So multiples, we mean you just say 3 multiplied by 260, 2 multiplied by 360, and all that. So and we'll always end up with an angle in the first revolution. So example number 8. Let's say you're given sine 495, sine 495. So this will be sine 495 minus 360. You subtract 360 for you to get in the revolution. So it will give you in the revolution, it will be sine 135. So that sine 135 is equivalent to sine 180 minus 45, which is positive. Sine, it will be sine 45, and then which is equivalent to root 2 over 2. So now let's look at the negative angles. So always remember that negative angles are in the fourth quadrant. In other words, you move clockwise. You move clockwise. Okay, now check this out. So suppose you're given sin theta, it will be negative sin theta, because in the fourth quadrant, sin is negative, so you write negative sin theta. So for cos, it will be cos of negative theta, it will be positive cos theta, because the cos is positive. So now, suppose you're given tan theta minus 180, for example, you have to manipulate here. You just say tan of solid bracket minus, you take common factor of negative which will have 180 minus theta. So here is tan there is tan negative in the fourth quadrant. Yes, you take out the negative. Here you take out the negative out, then you are left with tan 180 minus theta. So 180 minus theta is also a negative. You left negative tan theta, which is equal to negative and negative is positive. You got tan theta. So here, check this out. We'll also explain this. So you'll do the same. Sine of theta minus 90. So you take out the negative, you will have 90 minus theta. Sine is always negative there in the first quadrant. So you'll have negative sine of 90 minus theta. And then sine of 90 minus theta, this is a cofunction. It means that it must change. It will change to cos theta. That's why you've got negative cos theta here, because here is a cofunction. Sine is a cofunction of cos at the 90 degrees. So look at this again. Cos of theta minus 90 is equals to cos of, so you take out the negative, it will be negative into 90 minus theta. So cos in the first quadrant is positive, right? Plus. So you'll have cos of 90 minus theta, which boils to sin theta, because this is a cofunction, right? Now, let's look at the example number 9. Determine the value of the expression without using a calculator. So now, cos of 420, you can manipulate this. Sine of 225, you can manipulate this. This is a special angle and negative angle. Tan of 315, you can manipulate this using a special angle, obvious. So now, this will be cos of 420, it will be 360 plus 60, and then sine of 225, it will be 180 plus 45. And then cos of negative angle over tan 315, it will be 360 minus 45. So now here you are 360 plus, you've got cos theta, and then here 180 plus is negative, and then you write negative sin 45, and then here is always positive, it will be cos 45, and then 360 here is also negative in the first quadrant, you've got tan 45. So now negative and negative, it will be positive. In other words, you've got cos 60, which is half 1 over 2 plus sin 45 1 over root of 2 here, and then cos 45, which is 1 over root 2 here, negative. Tan 45 is 1 over 1, which is negative 1. So now here you can come and manipulate root 2 multiplied by root 2, which is 2, and then you can come and manipulate 1 by 1, which is 1, and then you've got this 1 over 2 here, right? So you've got negative from the denominator, you can just write it negative here, you take it out, and then 1 half plus half is 1, so which is negative 1. So now let's look at the home task. So simplify the following. This is your home task, guys. You can write it in the comments. Number A, number B. This is simple. Number C, it's also simple. Here you just manipulate using reduction formulae, and then also here you use the special angle here on number E. On number D, you also use a special angle. Number F, you also use a special angle. The rest here, A and B, you use the reduction formula, but which is the same. And if you've got any question, you can write on the comments. Thank you, guys. Don't forget to like, share, and subscribe to the channel.